All right, PreCalc 4.6, graphs of other trigonometric functions. We graphed the sine and cosine curves earlier, so today we get to go to the rest of them, tangent, cotangent, cosecant, secant, okay? We're going to see similarities, but there's a lot of differences in these graphs, and especially how these graphs look. One thing I want to stress to you when we worked on our unit circle is if you remember filling out the really big chart with all the values for the sine, cosine, tangent, cosecant, secant, and cotangents, that in the cosine and the sine columns, we never had an undefined term. It didn't matter what we did, but we always, because if you think about it, it was always one of those coordinates. So it was, you could have 0, you could have 1, you had those fractions, but you never had an undefined term. When you got to the tangents, and then later the cosecants, the secants, and the cotangents, we did end up with some undefined terms. So because of that, we have some x values that we can't use because we can't create those undefined terms on a graph. So because of that, what you're going to notice is a lot of asymptotes or lines, guidelines that we get closer and closer to, but we don't touch, things like that because of this, okay? So let's go over some main characteristics here of the parent function of a tangent, okay? And that's where we have to focus on is the parent function. So what you see in this graph right now is the parent function of the tangent, okay? Some highlights that I really want to make sure we understand. There is a period of pi, okay? This section of this graph right here, I'm going to highlight it. This is one entire period. That is one cycle of this graph, okay? It's pi. Now, notice it goes between negative pi over 2 and pi over 2, okay? If you remember, pi over 2 or 90, the tangent is undefined. So because of that, I have an asymptote at that value. And then, of course, every odd pi over 2 value, I end up with more asymptotes, okay? Do you remember for period, the pi there? We said this before that for cosine and sine, it takes a full circle 2 pi to repeat the values in the order they are. But for tangent, every half circle or pi, it repeats the values. So because of that, our period is just pi. Our domain, we can't plug in anything and everything we want because we would end up with those undefined terms. So it's everything except the odd multiples of pi over 2 as the parent function, because as soon as we transform anything, translate it anywhere, that could change. The range, though, is all real numbers, okay? So we do get range of all real numbers because you'll notice that our arrows are going down and up from our graphs here. So we have these arrows up and down. They're going to hit every y value. We can't plug in everything we want, so my domain has limits on it, but my range, it goes through everything. And if you think about it, too, even your tangents in some of them, sometimes you had radical 3, sometimes you had radical 3 over 3. Those values are larger than 1, right? But we never had a value larger than 1 on a sine or cosine. Vertical asymptotes are those odd multiples of pi over 2, and again, that's on the parent function. We could have that shift if we did any type of phase shift. An x-intercept occurs midway between each of the consecutive asymptotes. So we have this intercept right here, okay? And that's important. We're always going to see that intercept. The only time it wouldn't land on 0, 0 like this is if there is either a horizontal or a vertical shift. And then I'm going to jump kind of from this one down to this one, okay? We have points on the graph 1/4 and 3/4 of the way between the consecutive asymptotes with the y-coordinates of -1 and 1. On this parent function, this bottom one is at -1, and then this top one's at +1, okay? I do want to make sure you realize, kind of like a linear, if we have our graphs kind of going in these directions. If you talk about end behavior on one curve, right? We start low and we go high. It's important to recognize that with this because as we join reflections in there, as we do any type of reflections or change to a cotangent and stuff, some of that changes. So remember for this tangent, that's kind of my end behavior. This is an odd function, which we already know earlier that tangent was always odd. But again, you can see this because if we turned it on the origin 180 degrees, it would look like itself. So we can see it in a visual now, but we already knew that that was an odd function, okay? All right, so let's talk about how we're going to graph this, okay? And notice this whole front page is simply notes, okay? And I copied them from the book. They're not my own, but I want to go through a couple of these. Okay, our period. When we find the period for a tangent function, very similar to what we did on a sine and cosine, but it's going to be pi divided by b, not 2 pi divided by b. So we're going to find a period of a tangent function with pi divided by b because it repeats every pi. Okay, my phase shift. If I ask you for a phase shift, it's still going to be c divided by b, and we have to remember that that c needs to change to the opposite sign, okay? So those kind of things, a slight change in the period, phase shift doesn't change, those are still going to be true. Now, I'm going to throw in, though, and we're still going to do the period. It's still 4 spaces out. That's not going to change. But I'm going to be honest on the phase shift. Beyond identifying it, we probably won't use that to graph as much because this is what I use to graph. My normal asymptotes are negative pi over 2 and pi over 2. So if we put that between bx minus c, or I should say put bx minus c between those two values, and solve for x, it will give us any different asymptotes that come because of a change in a period or a phase shift, okay? So if you can remember to go and do this with every tangent one, just take whatever your bx minus c is, put it between the negative pi over 2 and pi over 2 and solve for x. That will give you the two asymptotes you want to start with for one full period, okay? So we would find those two asymptotes, we graph them, and then halfway between them we get our x-intercept, and then we graph our low point and our high point, which is going to go with our amplitude. Usually it's -1 and 1, but if we happen to have an amplitude, that'll change. And then we draw our curves, okay? We can repeat those if necessary. All right, so there's our basics. Let's go try it, okay? So page 2, let's try some of these tangent curves. You'll notice, again, my graphs for you are very vague. I just basically give you just kind of some axes to start with, and it's important that you label them so we know what they are. Okay, so it does ask us to identify the period and the phase shift of these graphs, okay, and then sketch at least one cycle or one period of this function. Okay, my amplitude. My amplitude goes to my A, right? And in this case, my amplitude is this invisible 1, so it's just 1, which means my highest point. No, I shouldn't say that anymore. I have a value at 1 and a value at -1, but it's not my highest and lowest because for the range, it keeps going higher and lower forever. Okay, for my period, remember it's going to be pi over b, okay? And my b comes from this value right in front of my x, which is 2. So I'm going to get pi divided by 2. Well, there's not much more to do that, so that's what it is, pi over 2. That means 4 lines out. I can make pi over 2. So that, the 4 line out thing is not changing from our sine and cosine. We still hold that's going to be my period. Okay, which means halfway between is like pi over 4, right? Halfway between that and that, pi over 8 would, so each of my little increments in this graph really stand for pi over 8. All right, I'm going to identify my phase shift. I'll go ahead and do it right here and then I'll finish this. So phase shift is C over B. Well, because C does not exist, right? It's 0, and 0 divided by 2 is just 0, so there's no phase shift. Okay, to graph this, I want my asymptotes. Now, the normal would be at pi over 2, negative pi over 2 and pi over 2, but because we've had a change in period, we know that there's a slight change. So the best way to do this is remember to take your bx minus c and put it between pi over 2 and negative pi over 2. Remember, it doesn't equal it because those are asymptotes, so we don't have the equal sign, but we just go from there. Okay, my particular bx minus c on this one is 2x. Whatever's there with the x, either grouped with a parenthesis or tightly connected, which that 2 is. So this whole thing is going to be 2x. Okay, you can split it into 2 separate ones, or you can just divide everything by 2. Okay, so think about this. Negative pi over 2 divided by 2, which is the same thing as keep, change, flip. So I get negative pi over 4. Okay, so I get negative pi over 4 is less than x is less than, so pi over 2 divided by 2 will also be a pi over 4. It's just positive. Okay. My pi over 4 is already here 2 spaces out, so I'm going to put an asymptote there, which means my negative pi over 4 is 2 spaces to the left here. Okay, so those asymptotes are super important. When you graph this, it's important that you label where you're at on the graph when you put that asymptote, and you show me those asymptotes. If you can't bother to put that asymptote there, I'm going to mark it wrong because I don't know where your curves are approaching. Okay, now for the graphing part. Halfway between those is my x-intercept, so I have a nice dot right there at 0, 0. I have no reflection, so I'm going to follow the normal, start at the bottom and go up towards the top. Nothing changes on that. And so my amplitude is 1, which means my bottom value is down 1 on the left, and my right value is up 1 on the right. So those are points I'm going to look specifically for. And then my curve just follows my asymptotes for the rest of that. And there is one period of that function. Not what I'm trying to do here. Okay, so let's get our page to move here. Let's do another one. Again, a lot of these changes, remember, I'm kind of throwing more at you today than I did yesterday. We took it in a little smaller steps because we should be getting used to the A, the B, the C, and such from there. Okay. Graph y equals negative 2 tangent of x over 4. Okay, so a couple of things here. My amplitude. Well, my amplitude does not include a sign ever. It's always an absolute value, and it's going to be my A, right, which is 2. So that means I know I'm going to go as high as positive 2 and as low as negative 2 as far as significant points, right? Okay, just a quick note that negative, all that's going to do is give me a vertical reflection, okay? And we'll come back to that as we graph, but just know that I do see that negative, but it is not part of the amplitude, it's part of a reflection. Okay, I need a period. And the period is always going to be pi divided by 2 over, I don't know why I put that 2 there. I'm thinking parabolas, I guess, divided by b. And my b right now, be careful here, is 1/4. That's like 1/4 x, so my b is 1/4. So I have pi divided by 1/4. That's the same thing as keep, change, flip. So it's really going to be 4 pi. So 4 lines out is my 4 pi. Halfway between that is 2 pi. That means all my increments are just pi at this point. Okay, so I get a negative 2 pi over here and such. Phase shift. So my phase shift is based on my c divided by b. Do I have a c? No. My c is 0, so no phase shift. Okay. I need my asymptotes. So the best way to do it is to put x over 4. That's what's there behind my tangent right there, right? That's my bx minus c. And I'm going to put it between negative pi over 2 and pi over 2. Every time I deal with tangent, I start it out between negative pi over 2 and pi over 2. To get x by myself, I need to multiply by 4. Whatever I do to the middle, I have to do to both sides individually. So 4 times negative pi over 2 is going to be negative 2 pi. And pi over 2 times 4 is going to be positive 2 pi. So at negative 2 pi and positive 2 pi, I need to see those asymptotes. Okay. And I start halfway between, I get my first point. Okay, now, a couple things we have to remember. I had an amplitude of 2, and I have this negative reflection. So that means instead of starting and going from the bottom up, my negative reflection, obviously they didn't want me to show that, huh? All right, my negative reflection is going to go the opposite, and I'm going to go flip that. So instead of starting down 2, I'm going to start up 2, and then I'm going to fall down 2 because of my amplitude. So I end up with this curve that goes like this. Okay, I'm looking for these points at 2, at 0, 0, and then down 2, okay? At 1, negative 2 there. It's not 1, it's 1 pi negative 2, right? And there's one of my cycles of that function. All right, let's try another one. The more we try, the more we practice, the easier these get. Identify the period and phase shift of this graph. Sketch at least one cycle. Make sure we're labeling everything. Okay, so my amplitude is my A. It looks like it's invisible right now, which means it has to be 1. So I'm going to go up as far as 1 and down as far as -1 with significant points. My period is going to be pi divided by b, always pi when we're dealing with tangent. And currently what's being multiplied times my x looks like it's a 1. So it looks like my, give me a minute on this. Okay. So my b, it looks like is 1. By the way, my c is opposite what I see right here, so it's just pi. We'll come back to that. So pi divided by 1 is just pi. So 4 lines out is pi. Halfway between that is pi over 2, which means each little increment would be in pi over 4. All right, phase shift, because we definitely have one this time around, is going to be my c over my b. Well, we already established that c is pi. It's opposite the sign. So I'm going to do pi divided by my b, which is 1. So my phase shift is just positive pi, okay? Now, I can go ahead and try to do that, or if I just figure out where my asymptotes are, it takes care of my phase shift for me. So this is more of an identifier, but if I just do my bx minus c, which is x minus pi, right, whatever's in here is my bx minus c, and put it between negative pi over 2 and pi over 2, okay? When I do the math here, it will take care of that phase shift and do that on the graph for me. So this time I'm adding pi, and I add it, I don't know what I just did there. I'm going to add pi on everything. Okay, so negative pi over 2 plus pi over 2 gives me a positive pi over 2. In the middle, those pi's canceled. I'm just left with x. Pi over 2 plus pi gives me 3 pi over 2. Okay. That's the two places I need to have an asymptote at. So I need to go to pi over 2 and put an asymptote. And that's my left asymptote. And I need one at 3 pi over 2. Well, every 2 lines is a pi over 2. So pi over 2 pi, then I get to 3 pi over 2 over here. And that's where my next asymptote needs to go. Remember, if you do this correctly, you always end up with those 4 spaces between, similar to the 4 spaces from before, right? So halfway between is at 0, 0. I do not have a reflection this time, so I'm going to start low and go high. And I have an amplitude of 1, so my bottom one is at -1. My top one is at +1, and I'm ready for my curve. Okay? All right, so those are tangents, okay? Start low, go high, that fourth thing, and it's really, really important to remember that the key values we want to use to find our asymptotes are negative pi over 2 and pi over 2. Let's move on to cotangent, and you'll see why I keep stressing those values and the way that graph goes, so we see the difference between these graphs. Okay, so this is the directions for the cotangent curve, okay? Does it look similar to the tangent? Sure. Here's some big differences, though. It starts high and goes low. That's its normal, okay? In one full period, and I want to highlight it like I did this one, the normal period starts at 0 and goes to, wow. Just a minute. I don't want to mess these up any more than I have to. Okay, it goes between 0 and pi. Instead of negative pi over 2 and pi over 2, it goes between 0 and pi. That is one full cycle right there, okay? My period is still pi. So anything with tangent or cotangent, the period is pi. The domain this time, it's all real numbers except the integral multiples of pi, because remember there's that slight shift, so our asymptotes are now on the pi's instead of the pi's over 2. Range is all real numbers because those arrows keep going on and on forever. We get these vertical asymptotes. we get an x-intercept that's midway between the 2 points. It's still an odd function. We can turn it 180 degrees, and it looks like this. These are not new things for us because we already knew cotangent and tangent shared similar properties as far as odd functions. Okay, so once again, we'll just state it. We're going to find the period just like we did on the tangent as pi divided by b, right? Not 2 pi, but pi divided by b. And once again, we can find our asymptotes, but be careful, put your bx minus c between 0 and pi. Your phase shift, okay, that doesn't change. Your phase shift is still going to be c over b if you just want to identify the phase shift. C is opposite what we see it as, okay? We're going to go halfway between again with that x-intercept. We're going to get our points on either side of it. The normal, remember, starts up high and goes down low at our A and our negative A, okay? So just remember that's our normal unless there is some change between amplitudes or between periods or phase shift and so on, okay? So let's go ahead and graph some of these so we can see these. So the first one here, I'm going to graph y equals 1/2 cotangent x. Okay, so my A, my amplitude, right, is my A, is 1/2, okay? So if this is 1 and this is -1, I get a 1/2 and a -1/2. It helps if I scale these consistently, doesn't it? Okay. So remember, my amplitude is 1/2. That's going to affect the points that I draw kind of at the end. Okay, my period. It's affected by whatever's multiplied times my x. There's nothing multiplied, so my b in this case has to be 1, right? I apologize that everything's getting knocked around here and it's just a mess. Okay, b equals 1. Just for reference, there is no c right now, right? Okay, so the period is pi divided by b. So that means pi divided by 1 or just pi. So 4 lines out is pi. And that means halfway between it is pi over 2. Okay, phase shift is c over b. Because c is 0, there's no phase shift. Okay, but the best way to find my asymptotes is to set up my bx minus c. This time, remember, between 0 and pi because I'm dealing with cotangent and not tangent. So I really don't have anything except x in between there, which is fine because what that does is it sets it up. I need to put my asymptotes at 0 and pi. So no questions there. I have a 0 asymptote. I have a pi asymptote. Okay. Halfway between it is one of my points, so I have a point right there at pi over 2. Remember that on the cotangent, I start high and I go low. So to the left, in that 1/4 spot, I'm up to 1/2 because that was my amplitude. On the right-hand side of my middle there, would be 3 pi over 4, I'm going to be down at -1/2. And then I'm going to draw my curves to follow my asymptotes. And there's a cotangent curve. Let's do one more cotangent down here at the bottom of the page. This time my amplitude is my A, which is 3. So it means I'm going to go up as high as 3 and down as low as -3. All right, my period is pi divided by b. And b is whatever is multiplied times my x. Right now it doesn't look like anything is, so my b must be 1. And by the way, my c is opposite what I think it is, so it's -pi over 2. So pi divided by 1, which is just pi. So 4 lines out is pi. And then halfway between that is pi over 2. All right. Phase shift, I think I have one this time. This is going to be c over b. And my c this time is -pi over 2. My b is 1. Well, that makes it easy. It's just -pi over 2. And remember, using that setup of C over B, it identifies where it should shift, but the easiest way to shift our graph is to put our bx minus c, which is x plus pi over 2, in between 0 and pi. Remember, 0 and pi for cotangent, negative pi over 2 and pi over 2 for tangent. So I'm going to subtract a pi over 2 on both sides. Well, 0 minus pi over 2 is negative pi over 2. In the center, my x pi over 2 is canceled. Pi minus pi over 2 is just a pi over 2. Okay, so I have asymptotes now at negative pi over 2 and pi over 2. Halfway between it is one of my points. I'm in cotangent, there's no reflection, so my highest point will be where I start on the left, and that's all the way up at 3. My lowest point is down at negative 3, and I'm going to follow those curves, okay? All right, there's my cotangent curve. So a couple things to note. If I didn't have an equation for this bottom graph, and I first looked at it, would I think that was a tangent or a cotangent curve? And we can say cotangent because it starts up high and goes low. But if you flip back on your page and you look at one of my reflected tangents, okay, like example B, there's a reflection, that looks like a cotangent curve, right? This particular one has the asymptotes. On this one, we're looking at example D here at the bottom on my cotangent. It has asymptotes that we often see with our tangent curve, okay? But because of the phase shift, it doesn't mimic the asymptotes of the cotangent curve as much. So kind of the same thing when we talked about the sinusoidal graphs of sines and cosines. When there's phase shifts, they start to look like each other a lot. With there's reflections, they kind of look like each other a lot. So the important thing is take what you have and graph what you're given. And it's okay if a tangent curve looks like a cotangent or a cotangent curve looks like a tangent, as long as you've followed the proper transformations on those, okay? But the key things I'm looking for in your work are, did you set up a bx minus c between 0 and pi for cotangent, or between negative pi over 2 and pi over 2 for tangent? Those are the things that are important. All right, so tangent, cotangent, we're done. Let's move on now to cosecant and secant. Okay. Yeah. What we see right here on this picture is a cosecant curve. And what I need to stress to you is what is in solid lines is my actual graph, okay? So this, and I'm doing cosecant, so I'm sine. This right here, oops, would help if I could kind of follow the line a little better. This curve right here, okay, and this curve right here, and all of this right here, this is one period or one cycle of the graph, okay? And the graph, technically, if somebody said, what does my cosecant curves look like, would be those two U's, the upside down one and the one that's right side up. That's the graph. Everything else in the graph are my asymptotes or my guidelines, okay? Because we have cosecant that goes back to sine, I'm back to a period of 2 pi, okay? My domain, all real numbers except these multiples of pi. If you go back to your big chart, you remember that when we had a sine of 0, that was fine, okay? But when we try to flip that, it becomes undefined, so I can't have every cosecant value because I can't have those undefined values. So I do end up with asymptotes on my cosecant curve that I didn't have on my sine curve. My range, okay? If you notice, really I have everything except between -1 and 1, because it's kind of that flip, that reciprocal of, it's not kind of, it is the reciprocal of my sine curve. So I'm not going to use the values used in my sine curve. I'm going to use all the other values that weren't used in my sine curve, okay? I have these vertical asymptotes. This is an odd function because sine's an odd function, cosecant's an odd function, okay? So how do we graph these? That's the key thing, okay? And I don't really have these written directions, so it's super important you're watching this example and you're taking note of what I say. I'll try to write some extra notes here and there. Okay, so when you go to graph a cosecant function, what the basic thing you need to start with is you need to draw the sine function that goes with it as the, quote, another asymptote or guideline, okay? So the first thing I'm going to do here is I'm going to graph, instead of y equals 3/2 cosecant x over 4, which I'll get to, I'm going to start with y equals 3/2 sine of x over 4. Super important that we remember that sine and cosecant are reciprocals. So we're going to graph the sine first, and when I say I'm going to graph it as a dashed line, okay, because this is going to be my guideline or asymptote. Okay, so off of this graph, using what we know, my amplitude is 3 over 2. Okay, so I know that if this is 1 and this is 2, right, I'm going to be halfway between those at 3 over 2. My period, remember I'm back to kind of using the sine, so it's going to be 2 pi over b. And it looks like my b here is 1/4, right? So I'm going to be 2 pi divided by 1/4, which is the same thing as keep, change, flip, so I get 8 pi. Okay, so 4 lines out is 8 pi, which means halfway between that is 4 pi. All right, my phase shift, I need to worry about that, or check to see if there is one. My phase shift, C over B, because I see no plus or minus in with that X tightly held by a parenthesis, right? C is 0, so no phase shift. Okay, so here's the deal. We're graphing this curve, okay? Sine, remember, because there's no phase shift, we're going to start at our 0. Sine always starts at 0. It's going to end at 8 pi, right? And we're going to go up to our amplitude on the first one, which is 3/2, back down to the center, and then down to our amplitude, which I'm trying to... I want to make this as legible as possible is what I'm trying to do here. So I have a 4 pi and an 8 pi. Wow, that doesn't look like an 8. Okay, so I'm halfway between down here at this 3/2, right? Okay, I'm going to dash this, right? Can you tell I'm dashing it? I don't want that to be a solid curve because it is not my graph. Okay, so we dash our sine curve. Okay, that's the first thing. So the second thing I want to do is place asymptotes. And I'm going to say vertical asymptotes. Everywhere the sine curve crosses the x-axis. I'm going to say the 0 line because I'll tell you why later I said this. Okay, so I have an asymptote here. I have an asymptote here, and I have an asymptote here, okay? So every time I cross the x-axis or that 0 line, I'm going to have an asymptote. And now all I need to do is to finish it out, and I place a U shape, whether it's upside down or right side up, on the top curve and the bottom curve. Okay, I'm going to do it in a different color so you can actually see it. So everything on my graph so far, it's needed. I need to see those things, but they're not part of it. So my actual graph, I start here at the top curve. By the way, it touches, okay? That guideline, I don't like to really call it an asymptote because I actually touch that, okay? It touches the top of that curve. It's so important it touches. Don't have it hanging off there. And I make a U between those asymptotes. And so this bottom one touches that at that negative 3/2 mark because of my amplitude, and I go from there. So the red curves are actually my graph. But I need all those other values in there so that I see where I found my guidelines and such like that. There's one period right there, one cycle of that function. Okay. So let's try this again, another cosecant one, okay? I'm not going to write out quite the details now because we kind of know the rules. So if I see cosecant, the first thing I'm going to do is I'm going to graph my y equals negative 1/2 sine, because sine and cosecant are reciprocals of each other, pi x. Okay, so my amplitude is going to be 1/2. And remember, that means the negative puts a vertical reflection. And the vertical reflection is on the sine curve, okay? That is going to come through on the sine curve. My period is going to be 2 pi, because we're back dealing with sine, divided by b. 2 pi, my b this time is pi, interesting. Anything multiplied times the x is going to affect that period. Okay, so 2 pi divided by pi is 2. That means 4 lines out, I'm at 2. What am I writing? Don't know. Halfway between that is 1. Okay, we have -1, -2 when we're looking at that. By the way, I'm going to make the 2 lines up this so I can do my 1/2 in between. Okay. Phase shift. Well, I don't think there's a C, right? There's no plus or minus with my x, so C over B. C is 0, so no phase shift. Okay. So some things to remember. So sine always starts at 0. So I'm going to start at 0 because I didn't do a phase shift. I'm going to end at 2 where my period ends. Normally my graph goes up and then it comes back down, goes underneath, and goes back to where it starts. But because of this reflection, right, I'm going to actually start down. So I'm going to come down to my lowest point, back up to my highest point in here, and I'm going to dash these. Okay, so there's the sine curve I needed to graph. Okay, so the next thing I'm going to do is asymptotes. Okay, I want an asymptote everywhere across the 0 line, because those would be my undefined terms. And now I want my curves. Okay, so I'm going to switch colors here just so we can see it. So my actual graph here, this time I have one down here that's going beneath. Because of that reflection, I end up with one down, and then one up because of that reflection. So important when you're graphing these that you label your axes with enough points so I know that your period is represented there, that you show me where your asymptotes are, all those kind of things, okay? All right, last page. We still need to do some secant ones, okay? So you should kind of have in mind, well, I know how I did the cosecant ones, so secant ones should be similar, and they are going to be similar. Your period's still 2 pi. The difference, obviously, is you're going to start with the cosine curve instead of the sine curve. So one full, what we would normally do this, and this is what I want you to kind of really notice here, is here's one full cycle, okay? As much as I keep saying draw these U's, because the cosecant, or the cosine, sorry, starts up and ends up, you end up with some like half U's, which is fine as long as your full cycle or your full period is represented, okay? Just a reminder, this one ends up being an even function because your cosine's an even, so your secant's an even function, right? So we could fold it, the parent function, right on that y-axis, and it should be symmetrical from left to right. All right, so what are our steps here? So similar to where we started on the cosecant, but this time we're going to graph, because secant and cosine go together, we're going to do y equals cosine of x over 3. Okay, and remember that's going to be dashed because it's a guideline. It's not the actual curve that's part of the secant curve, okay? So on this one, I have an amplitude of 1 because my a is 1. For my period, it's going to be 2 pi divided by b because anything with cosine is 2 pi. So 2 pi divided by 1/3. If you look up here, my b up here is 1/3. So that's the same thing as secant 2 pi times the reciprocal, which is 3 over 1, which is 6 pi. Okay, so 4 lines out is 6 pi. Halfway between that is 3 pi. Okay. Phase shift is C over B. It does not appear I have a C, so no phase shift. Okay, so remember, we're ready to graph this now. I guess I'm up at 1 and -1, right? Remember, a cosine begins at 1. It goes up to 1, and it's going to end up here in my full period up at 1. I go down to 0. I'm down in between here. I'm going to erase this 3 pi so you can see my point. Okay? And then I'm back here. Now remember, this is all dashed. So this is my cosine curve dashed. Okay? I know I'm not great on that curve there. Then we're going to, once again, we're going to place vertical asymptotes. Where the everywhere the cosine crosses the 0 line. Okay, so notice here, I'm only going to end up with 2 asymptotes shown in this one cycle, okay? And then finally, we're going to place curves. So notice here, the half curve. I'm up here, and I'm going to follow here. I started at 0, so I don't want to go to the left at all. I come down to my lowest point, and I put my full U here, and then I get this half on this side too, okay? You're going to get this a lot more frequently on your cosine because of starting up and such. You're going to kind of have this split in the one cycle. Similar, though, to what we did with the cosecant and sine curves, but this was with the secant and cosine curves. All right, one more, and I'm going to throw a, hopefully not too much of a confusion in here, but I do want to state this one, okay? Okay, I have a secant, so once again, I'm going to start by graphing the cosine that goes with it of 2x plus pi over 2 minus 1 out here. It looks like I'm throwing a little bit of everything at you, so let's decipher a little bit. My b is 2. Okay, because that's what's multiplied times my x. My c is opposite of what's inside that parenthesis, adding or subtracting, so it's negative pi over 2. And my d is negative 1. Okay. I need to kind of start with that d of negative 1. So what that says is instead of using my x as my, my horizontal line that I use, I'm actually going to drop it down negative 1. Okay? So I'm going to draw this new, and by the way, that's what I would call my 0 line. I'm going to take my 0 line and I'm dropping it down 1, okay? My my amplitude is 1 because that's my value in front of the secant, and there's nothing there. My period is going to be 2 pi over b because I'm dealing with cosine. So it's 2 pi divided by 2, which is pi. So 4 lines out, I have pi. Halfway between that is negative pi over 2, okay? I have a phase shift, which is c over b. My c was negative pi over 2. I'm putting that over b, which is 2. So that's a negative pi over 2 divided by 2, which is the same thing as negative pi over 2 times the reciprocal of 1/2, which is negative pi over 4. Okay, remember when we dealt with cosine, when we have a phase shift, that means instead of starting at my 0 line, I'm going to start at pi over 4, or in this case, negative pi over 4. If you look at the scale I have, 4 lines out is pi. Halfway between that is negative pi over 2. So my negative pi over 4 is actually this first mark to the left, okay? So I'm going to start at that one. And I'm starting up 1. Well, I'm starting up 1 from my 0 line. So I'm actually going to start right here, okay? Because that's up 1 from my 0 line. So then I'm going to hit my 0 line on my next point. Then I'm down to my lowest point because my amplitude on all this is 1. I'm back up in the middle, and I'm going to end it right here, okay? So that's my actual curve. I'm going to actually do that, highlight that in a different color so you can kind of see that around all my other lines, okay? There's my points I'm trying to do, and I'm doing this as a dashed line. Remember that. This is all still just my cosine curve, which is going to be a dashed line. Okay, this is where I really want you to notice this, okay? I need asymptotes at the zeros, okay? So because my 0 line moved, I need asymptotes still where it crosses my 0 line, okay, which in this case is not my x-axis right now because it dropped by 1, okay? That's where I need them. They need to line up with my 0 line, not my x-axis at all point times, but my 0 line, okay? And then I need my curves. I'm going to go back to my blue to finish this out here. So at this highest point, I'm up 1. At this down point, I'm down here. And then at this highest point, I have a curve as well. Okay, so those are my curves, my secant curves, coming off all these guidelines. So the cosine curve is a guideline, my asymptotes are guidelines, and I draw them off of that. Practice, practice, practice. The more you practice, the easier these get, okay? So go to page 546, try as many as you can. If you need to look up your answers in the back of the book, do the odd ones. If you feel good going on Slater, after you've tried them, you look up the answers, okay? Ask me if you have questions. Request Google Meet or something if you need some help with these. Let me know.